We're going to talk about intercepts to start out with, algebraically and graphically. So I'm going to show you, most people struggle with the algebraic part, so I'm going to try to concentrate as much as possible on that. But I can also show you the calculator version as well. We're going to do a lot with intercepts, x-intercepts and y-intercepts. And the x-intercepts are the same things as zeros and solutions. So if you see x-intercepts, zeros, solutions, they all mean the same thing. You might want to write those down. We learned the technique last week that kind of looked like this. Make an x and y table, plug in a 0 for the x, plug in a 0 for y, see what happens. So if I were to do that, and if I know that when I plug in a 0 for x, I have 4y equals 12, that means my y has to be 3. And then if I plug a 0 in for the y value, that means the 4y goes away, and 6x equals 12, so x has to be 2. And what this is telling me is that my x-intercept, which is where it crosses the x-axis, is 2, 0. And my y-intercept, which is where it crosses the y-axis, is 0, 3. Questions on 1a? If you wanted to, you could solve for y in this one on your calculator, which I'm not going to do. And then look at where it crosses the x and the y-axis. I think that's a waste of time. This is much faster. And I'm all about being efficient. So they say find the solution root of 0. Those three phrases mean the same thing. This really is talking about writing down the answer in a different way. It's the same answer. And so this is basically all three of these things that you see. Solution root of 0. Are all talking about where does the graph cross the x-axis? For math people, this is a very curious thing. And so what we're going to do is, since our x-intercept in that equation was 2, 0, when they ask for roots, zeros, solutions, they want, for some reason, for you to write it this way. X equals, and then the number. So when they talk about intercepts, they want you to write it as an ordered pair. And when they talk about zeros, roots, solutions, they want you to write it as the letter equals the number. Because they said so. In number 2, again, if at any time you guys have questions, just raise your hand, holler, whatever. We're going to use a calculator to find these answers, but I just want to point something out. First of all, the thing I want to point out is whenever you're looking for the y-intercept, that basically means plug in 0 for x. Or in other words, the y-intercept is 0, something. Now, if you're going to use your calculator for this, you're a moron. Don't do it. I put that on video. That's how strongly I feel about that. So look over the equation. Stop writing for a second and take a look. I have y equals blah, blah, blah. If I'm sticking a 0 in for x, gone and gone, the y-intercept is 5. Do not use your calculator for that. That would be ridiculous. In the second part, the x-intercepts, on the other hand, would be a good idea, I think, to use your calculator. And the x-intercept is when you have a number first and then 0. So the way that you're going to do this on your calculator is in y1, you're going to put down the equation. In y2, you're going to put in 0, and I'm going to show you what to do from there. So y1, put this equation, and y2, put in 0. And I can also show you how to do this algebraically shortly. So in your y1, you're going to put down x squared minus 6x plus 5, and then y2
What do you put on y2? 0. 2.
Sorry, I'm having a little bit of technical difficulty here. So x squared minus 6x plus 5, and then 0. Now if you go zoom 6, you are going to see a quadratic function, parabola, and you can't see it, but there's a horizontal line going across the x-axis. Now if I wanted to see that, I could go back to my y equals, arrow down, arrow to the left here, and this little blinky thing, if I hit enter one time, it makes it a thick bar, and then when I hit graph, I can see, after my parabola comes, I can see the horizontal line go through. Not that it really matters, but just so you know, if you want to see it visually, and something's going across the axes, that's really the only way you can see it. After you do that, the technique to find the intercepts on your calculator is second, trace, number 5 for intersection. It's going to ask you which one's the first curve. Don't even think about it, just go enter. It's going to ask you which one's the second curve. Don't think about it. Go enter. And then it says, where do you want to guess? And I tell people, arrow over to where you want to guess they're crossing. So the first crossing place looks like that to me. It's where the parabola and the horizontal line are crossing. And I hit enter. Oh, and look, it's crossing at 1, 0. So I can do that again. Second, trace, 5, enter, enter, arrow to the next place of intersection, or close to it, enter. Oh, and I'm crossing at 5, 0. So 1 and 5 are my two crossing places. So 1, 0, and 5, 0. In case you're wondering about that, it goes like this. Second, trace, 5, enter, enter, arrow back and forth to find the guess, and hit enter. This phrase I'll use all the time in this class. Second trace, 5, enter, enter, arrow, enter. Yes, ma'am.
Why don't we just look at the table?
What if the graphs were crossing at 1.7392? You'll be able to find that in your table? If the answer is yes, great. If the answer is no, that's why. So I always try to show the most efficient way that usually will work for anything, and that's why I picked this technique. It works for just about anything, if not all of them. The only one it might not work for is a vertical line, but then you already know where it's crossing the x-axis, because that would be a line like x equals 7, and it's crossing at 7. Anybody else? Okay, so I'm just going to briefly talk about how you do it algebraically. Bless you, I'm not going to actually do it. One way is you can use a quadratic formula. X equals opposite of b plus or minus square root of b squared minus 4ac all over 2a. And another way is you could factor. So in order to do those things, you would start out by taking this equation and setting it equal to 0. And then you could use the quadratic formula, or you could use factoring. So if I were to use factoring, which is I like because I'm pretty good at it, I would do x minus 5, x minus 1 equals 0. And the things that make these two parentheses 0 are 5 and 1. And that's how I got my intercepts, or my zeros. Okay, so that I use factoring when I can. And if I don't have to do it algebraically, I can use any technique. Calculator is very fast. Equation 1 is the equation 2 is the 0, second trace 5, enter, enter, arrow, enter. It's really convenient.